Mendeleev's periodic law. So this Mendeleev has given some of the idea to the periodic table. So he has arranged a little bit that okay, if the some elements are not discovered, he has given the space for that. But he found out the properties of the unknown element over here. So the Mendeleev's periodic law states that the properties of the elements are the periodic functions of their atomic masses. Okay, so actually, he has done one little mistake over here. Instead of the atomic masses, if he could have arranged it in the atomic number, he could have achieved the periodic table. But what the same mistake he followed from the previous observers. So he also arranged it in the increasing order of the atomic mass. So which is like that we are writing, right? The 16.949. So these are all the atomic masses. So, but he arranged little bit very correctly. So, lithium, sodium, potassium, rubidium, cerium. So, these are all the one which is having a similar properties. They have put it in the same group. Beryllium, magnesium, calcium, strontium, barium. So, this also it's having the same characteristic reactions. So, this also they have put it in the second group. The third group, boron, aluminium, and the yttrium. So, they have placed in the same group. But Mendeleev, he's a scientist, so he doesn't know what is the element is over here. So it's not yet discovered that time. So, but he has found out very correctly about that density. So what could be the atomic mass and what is the melting point, boiling point, what would be the color, how about the reactivity. So he able to find out all the stuffs over here, but he cannot able to discover that element. That element was nothing but the gallium. After they found out the element about gallium, so they have just matched with his findings. So it was exactly matched over here. Then he has made the carbon, silicon, titanium, zirconium and all in the same group, and nitrogen, phosphorus, vanadium and all. But still he has faced some of the problem over here is the transition series he has made this one, but still the titanium, vanadium, chromium, manganese. So these are all the metals. Okay, so but they have placed it in the non-metals group. So still it was unmatched over here. So again, this arrangement of the elements in the periodic table is also failed. So the next one is the Mendeleev's periodic table. So he classified the elements in the increasing order of the atomic masses and similarity in the properties. For example, suppose he has taken the water, cold water. So how the metals are reacting with the water. So what is the formula we are getting? So how many atoms are reacting, how many moles of the atoms are reacting in the reaction. So based on the properties, he has made this uh, table. So the formula of the oxides and the hydroxides was also based on about the classification of the elements. So sodium forms Na plus hydroxides it's from NaOH. So the sodium is having a plus one charge. Potassium also having the KOH. So potassium also in the plus one. So he has made the plus one charge in the same group. So plus two in all in the same group. But still he faced a problem with the transition metals because the transition metals are having a different oxidation states. So still he is confused that how to arrange this transition metals in the proper order. So, but he has given the horizontal rows called the periods. Still we are following the same thing. Periods and the groups. So he has given the name periods and the groups. Periods are nothing but that. So the horizontal rows. So this horizontal rows left to right, if we are moving in the periodic table, so that we call it as a periods. And the groups are nothing but so top to bottom. So how we are hydrogen, lithium, sodium, potassium. So this is nothing but the uh, top to bottom if you are coming. So that we call it as a groups. And the groups 1 to 7 had the two subgroups, A subgroup and the B subgroup. So here he has made the 1A and 1B, then 2A and 2B, 3A. So he has made the subgroups over here. So group 8 had the three rows of the elements. Elements have the similar properties they have made in the same groups. That's what I said. How the metals are, how the elements are reacting with the oxygen and how the elements are reacting it with the water. So based on the formula of the element, so he has made into the groups. There are some places left vacant in the table to accommodate the elements to be discovered in the future. So he has given some space over here. These are all the vacant spaces he has given. So in that time, that elements are not yet discovered. Merits of the Mendeleev's periodic table. So the elements were discovered on a more fundamental basis of their atomic masses and the properties. Yes, merits. So he has made the most fundamental basis. He's used the atomic masses to arrange the elements in the periodic table. And the spaces also left vacant to accommodate the elements to be. He has not like that before in the previous cases they have arranged like this. They have not even left a space for the undiscovered elements. But in this case, the Mendeleev left the spaces for the yet to discover the elements. So he can able to predict the properties of the elements which helped in the discovery of the new elements. Yes, he just predicted that what is the, so that's what I said. He has predicted exactly about the undiscovered element that is a gallium. So after that they have matched with that finding. So it's exactly matched with the same values. The inert gases elements discovered later could be placed in the separate cooled without disturbing the table. Yes. So in his period also, the noble gases are not yet discovered. So the helium, neon, argon, krypton, xenon. So there is a no space over here. So once they have found out about the noble gases, so they have given the one more column over here and they have made that as a noble gases. So these are all the merits of the Mendeleev's periodic table. Next one is the defects. What are all the defects in the periodic table is some elements are not arranged in the increasing order of the atomic masses. So example, the cobalt is placed before the nickel. Yeah. So here actually it is 58.9 over here, but the nickel is 58.7. So he could have placed that nickel over here and copper over here. So this mistake he has done over here. And the position of the hydrogen is not clear. Sorry, tellurium is placed before the iodine, etc. Yes, here also one more mistake is there. That iodine, yeah, tellurium is 120, iodine is 127. But what he has done over here is iodine is exactly matching with the fluorine and the chlorine. So that's why he has placed the iodine over here. So he knows that iodine also forms the -1 charge and bromine also forms the same thing. So he has placed these two in the same fluorine and chlorine group. But the tellurium is having a 128 mass number, but still he has not given the proper explanation for this. But the tellurium shows the exact reaction like chromium or the molybdenum. So he has placed the tellurium over here. And the position of the hydrogen is not clear because it shows the properties similar to the metals as well as the non-metals. Yes, so the hydrogen he has placed in the group over here, the first group he has placed. But he has not given the proper explanation why he has placed the hydrogen in the first one. Because it is like a metalloid. Because hydrogen is having one electron in the outermost shell. So what it will do is if it accepts the one electron, it will behave as a non-metal. It forms the H minus one. Suppose if it lost the one electron in the outermost shell, so it means that it behaves as a metals. So both the properties are shown by the hydrogen. So it behaves like a metalloid. For explanation, why he has placed the hydrogen over here. Till now we are placing the hydrogen in the same group. The position of the isotopes of the elements are it's not clear. Yes. So the next one is the position of the isotopes. What is meant by isotopes? Isotopes means so the atoms are having the same atomic number but different mass numbers. That we call it as a isotopes. It means that uh, protons, it's having the same number of the protons but different number of the neutrons. But why he has not given the proper explanation of the isotopes is in his period the neutrons was not yet discovered. So neutrons were discovered only in the year 1932 by Chadwick the scientist. So that's why he has got some doubt in that. So why the atoms are behaving like this? Because the neutrons, they are having a different number of the neutrons. So in that period he doesn't know what is that making a difference over here. So chlorine is having two chlorine atoms he has found it with the different atomic mass. So how it is possible? So he has not given the proper idea about the isotopes because the neutrons were not yet discovered.